We are all aware of the challenges of parenthood, but imagine the additional struggles of raising a child diagnosed with a life-altering genetic disease. A genetic disease is caused by a mutation in one's DNA that is inherited from one's parents. DNA mutations can be identified at birth, but in many cases, individuals are not diagnosed until later stages of childhood or even adulthood. During this segment, we'll be hearing from Dr. Melody to find out more about one of the most common genetic diseases, muscular dystrophy, and hear of the story of Carson, who was diagnosed 2 years ago with muscular dystrophy. So Dr. Melody, can you elaborate more on the causes and effects of muscular dystrophy?
DMD is a sex-linked recessive genetic disease found on the X chromosome. When DNA is replicated incorrectly, a mutation prevents an individual from producing a protein called dystrophin. Dystrophin is needed to maintain skeletal and cardiac muscles. Without it, the individual experiences symptoms that include trouble swallowing, breathing, and loss of motor skills. This is most common in young boys.
Cells play a huge role in our body. How are cells affected with muscular dystrophy?
An unequal amount of DNA crosses over in the process of meiosis, which is the division of cells that result into diploid or haploid cells. Then cells have an uneven amount of DNA, which results in them not functioning properly.
You previously mentioned that muscular dystrophy is more common in young boys. Why?
If a defective gene is passed down, there is a mutation on the X chromosome. A boy has only one X chromosome as opposed to girls who have two X chromosomes. Boys have a 50% chance of possessing the mutation if their parents are carriers because the mutation can only occur on the X chromosome. There is much less of a threat for girls possessing the mutation because they have two X chromosomes, and if one is mutated, it can be overridden by the non-mutated X chromosome. She is then considered a carrier and has the ability to pass down the defective gene to her child.
Is there a cure for muscular dystrophy?
Unfortunately, no, there is no cure yet.
Meet your genes.
Listen up. I'm a gene that impacts your muscle composition.
BTBD9 here. I could influence how much you move your arms and legs in your sleep. I'm a twitchy little gene.
We're two of the genes that may impact your risk for celiac disease.
We have a gluten situation. I'm linked to a Neanderthal trait.
Lactose intolerance.
Caffeine consumption.
There's a whole world of genes just waiting to meet you in over 90 genetic reports at 23andme.com.
Carson has been battling muscular dystrophy ever since he was diagnosed 2 years ago.
I have Duchenne's muscular dystrophy.
His parents first realized there was a problem when he began experiencing difficulties walking, standing, and balancing. The lack of protein synthesis is the cause of growth failure of muscle cells. This results in Carson's muscles not being able to function properly. As Carson gets older, he will continue to struggle to keep up with the kids and will inevitably end up spending most of his time in a motorized chair. Carson's disease has brought upon many struggles and hardships for his family, but they will continue to not let muscular dystrophy control their lives.
Who were your ancestors? Where did they originally come from?
A simple test from an Oklahoma company can unlock your family's rich genetic history.
Watch What's in Your Genes, tonight at 6 on News Channel 4.
To understand the effects of muscular dystrophy in one's body, we need to go where it all starts, the DNA. As a review, chromosomes are coiled DNA. People with muscular dystrophy will have a mutation or a mistake on their X chromosome. There is a gene on the X chromosome called DMD, or Duchenne muscular dystrophy. Dystrophin is a protein that is produced on the DMD gene. It holds up the structure of our cell membrane in our muscle cells. It's part of the group of proteins that work together to strengthen muscle fibers and prevent injuries. When dystrophin is not produced as a result of the mutation, the cell membrane of the muscle cells will collapse. CK enzymes then escape the damaged cell membrane. An increase in CK enzymes results in an increase in muscle damage. This will continue until the muscle mass is very minimal.
After hearing from Dr. Melody and Carson's story, we have gained a deeper understanding of genetic diseases and more specifically muscular dystrophy. We saw how Carson and many other kids are affected by muscular dystrophy and the genetics behind it. Thank you for joining us tonight on 60 Minutes.